Assalamu alaikum. This is Talha bin Nadeem, and today we are going to start off with a new topic, with a new chapter of the lubrication and lubrication systems. Um, I will record two videos of this chapter. The first video will be regarding the lubrication, and the second video will be regarding the topic of lubrication systems. Today I am going to start off with the topic of lubrication. Uh, this is the chapter number 13 of the book which we are following. I have shared that book uh, in the Google Classroom. Okay, now starting off uh, with some of the basic introduction that why do we even require the lubrication in IC engine. All of you must have seen that there are oil pans in the IC engine, and if you guys must have seen that your father or maybe your family members, some other family members would go to some mechanic shop to replace the oil in your car or maybe in the motorcycle as well. So um, what is the purpose of that lubrication oil? So the purpose of that lubrication oil is basically to provide the lubrication between the moving components. Because since the piston is reciprocating, it is reciprocating inside the cylinder, so there are the sliding component, there are the moving components, and we have to and because of this uh, moving components, there may have some frictional losses, and we have to minimize those frictional losses. And in order to minimize those frictional losses, what we do is we provide some lubrication oil to reduce the frictional losses. uh, how these lubrication oil lubricating oils basically reduce the friction, it is quite simple to understand that for example, eh, you have in your home, you will see that when you have a dry floor, you can easily walk on that dry floor. But if there is some water, if you spread some water in on the floor, there is a probability that you will get slip. And because why do you get slip? Because the water will act as a lubricant. It will reduce the friction between the floor and your foot, so there is a possibility that you may get slip. So that is what the lubricating oils are doing in the IC engine. They are basically reducing the amount of the friction between the moving particles, between the moving components. So in engines, frictional losses are mainly due to the sliding as well as the rotating parts of the IC engine. Sliding, as I mentioned earlier, as the piston is sliding inside the cylinder, is reciprocating inside the cylinder, and rotating components like a camshaft and crankshaft, they are rotating components. We also need lubrication in these crankshaft for and camshafts as well. Normally, in broader sense, when we are talking about the frictional losses, they are usually taken as the difference between the indicated power and the brake power. We have solved these numericals in the chapter number 1 as well. That if we take the difference between the indicated power and the brake power, we will get the frictional losses. We will get the frictional power, the amount of the power which will be required to overcome the frictional losses. So frictional losses are mainly attributed to the mechanical losses. So We have some different types of frictional losses. For example, we have direct frictional losses, means the losses which are between the sliding and the rotating components of the IC engine. They are the direct frictional losses. The second one is of the pumping loss. The fuel is being pumped from the fuel tank, and we have a oil pump as well, which is pumping the oil for the lubrication. So all of these losses are basically the pumping losses. Then we have a power loss to drive the components to charge and scavenge. This is basically talking about the superchargers and the turbochargers, that we have to drive those components which will take the charge into the combustion chamber, and it would not only be taking the charge, but would also be scavenging, scavenging would also serve would also do the phenomena of scavenging. And in the last, we may have some auxiliary equipments as well, in which we may have some power losses. So your lubrication system must provide the lubrication in all of these parts to overcome the frictional losses. This is basically regarding that where the frictional losses in your IC engine may occur. Okay, now moving forward, um, in the next part we will discuss that what is lubrication, and what are the functions of lubrication. I have in the previous slide I have explained most of the part, so I will quickly just go through the uh, basics of this topic. That lubrication is basically the admittance of the lubricating oil between the two surfaces which are moving relative to each other, and the purpose of the lubrication, there are many purposes of the lubrication. So what is lubrication? You can simply answer it that it is the admittance of the oil between the two surfaces which are in relative motion to each other. And what is the purpose, what is the function of the lubrication? So the purpose is to reduce the friction. This is the primary object, this is the primary function, to reduce the friction between the moving components. Second is to reduce the wear between the moving components, since for example, if these are the two surfaces, this is your piston and on the left side you have your cylinder. So here in these passage we will have some piston rings as well. For example, we have two piston rings, and here you can see if this is your piston, so the lubrication oil would be providing the lubrication in this section, in this clearance between the cylinder and the piston. So it would not only be reducing the friction, but if we do not have this if we do not have this friction, if we do not have this oil between these moving components, so what will happen here is these components will strike with each other, will collide with each other, and we can have a wear and tear between these moving components. So it is not only reducing the friction, this oil film is not only reducing the friction, but it is also reducing the wear and tear between the moving components. So these are the two main important functions. So the next important function of the lubricant is basically to cool the surfaces. So it is not only lubricating, not only reducing the friction and wearing, it is also cooling the surface as well. It is taking away the amount of the heat which is being generated during the combustion process. And the next function is to seal the space between the adjoining surfaces. Means it is sealing, it is providing a sealing between this cylinder and the piston uh, in this adjoining surface. Next purpose is basically to absorb the shocks between the bearings and the other parts of the IC engine. Ultimately they would be reducing the noise because of these shocks. And in the last, it is basically reducing the dirt and grit particles, and as a result of the removal of this dirt and grit particle, uh, if we do not have a lubricating oil, and somehow, let's say, if a dirt particle gets here, maybe from the fuel, or maybe from any other source, from, let's say, from the air, if that dirt particle gets here between these two surfaces, it will act as an abrasive material and will increase the wear and tear. So this is what the this is also the function of the lubricant as well, that it will take away that dirt and grit particle which is being trapped between these rubbing surfaces. So these are the 6 important functions of the lubricants. Number 1, to reduce the friction. Number 2, to reduce the wear between the moving components. Number 3, to cool the surface. Number 4, to provide the sealing between the adjoining surfaces. Number 5, to absorb shocks between bearings and other parts as well. Number 6, to remove the dirt and grit particles so that we do not have any abrasive material between the moving components. Okay, now moving forward, next we have the different properties of the lubricants. That lubricant which we will utilize in for the lubrication should have the above mentioned properties. The first one is the viscosity, the second one is flash point, then we have fire point, cloud point, pour point, oiliness, anti-corrosiveness, emulsification, physical and chemical stability, then we have neutralization number, adhesiveness, film strength, and specific gravity. I will discuss all of these properties in quite some detail. In this slide I have just written down the names of these properties. Okay, now moving forward, we have the first very important property of a lubricant, and that is of the viscosity. So again, viscosity, um, we all of have studied the basic concept of the viscosity. That viscosity is basically the resistance uh, which is being offered um, by the fluid against the flow. It is viscosity can be conceptualized as the quantifying value of the frictional forces which basically arises between the two adjacent layers of the fluid that are in relative motion against each other. Means, for example, if I have this pipe and the fluid is flowing, so fluid can be shown in the form of these layers. So the layer which is which are closer to the walls of this tube have the larger will feel the larger resistance against the flow, whereas the uh, layer which is towards the center of this pipeline, center of this pipe, um, will flow more effectively, more efficiently, because it will face the lesser resistance. And the resistance between these layers, these moving layers, is basically termed as the viscosity. So again, viscosity can be conceptualized as quantifying the frictional force which arises between the adjacent layer, between the layers which are moving against each other. And if we have a tube, the fluid will move more quickly near the tube's axis than near its walls. Means walls will offer the higher resistance as compared to the we will have a higher resistance across the walls, whereas the layer which is moving towards the center will feel the lesser resistance. So it is basically the ability of a oil to resist the internal deformation due to the mechanical stresses and the loads which are being offered by the moving components. So higher the viscosity, it means that it can bear the higher uh, loads which are being offered by the components of an IC engine, which are in relative motion. So it is the ability of a oil to resist the internal deformation due to the mechanical stresses. Hence, it is the measure of ability of the oil film to carry a load. More viscous the oil is, it can carry the greater load, but it will offer the higher resistance against the sliding movement. So this is the main difference, that if we have a fluid which is more viscous, obviously it can bear much larger loads, but if it can bear a larger load, it means it will also offer a great resistance between the sliding components. So we have to ensure that uh, that we are utilizing the desired viscosity fuel, desired viscosity lubricant. If we are using a much viscous uh, lubricating oil, it will offer a higher resistance against the sliding movement. So the next question is, what is the next thing which we need to understand here is that what is viscosity index. So viscosity index is basically the property, is basically the terminology which are being used, and it can be defined as that how much the viscosity of a fluid is changing with the change in temperature. So the greater the change in temperature, means if your lubricant oil is changing its velocity higher to a higher values, it means that it has a low viscosity index number. But if the change in the viscosity with the change in temperature is low, it means that it is maintaining its viscosity over the larger period of the temperature change. It means that it has a higher viscosity index number. So now viscosity index number is usually represented by VI. Viscosity index. A higher viscosity index indicates a relatively smaller changes in the viscosity of the oil with temperature change. Means that the changes in viscosity is small if the VI number of a lubricant is high. But if the VI number of the lubricant is low, it means that the change in viscosity with the change in temperature is high. So this is what the viscosity index number means. A high viscosity index means that we have a relatively smaller changes in viscosity of oil with temperature. The high viscosity index means that lower the rate at which the viscosity of the lubricant is changing with the increase in temperature. Again, we have studied this thing that with the change in temperature, if the temperature change is positive, means we are increasing the temperature, the viscosity will decrease. The greater the amount of the viscosity decrease, it has low viscosity index. The lesser the amount of the change in viscosity occurs, it means it has a higher viscosity index. But when we change the temperature, when we increase the temperature, viscosity will decrease, and when we decrease the temperature, viscosity will increase. So but viscosity index is showing that how much of the viscosity is changing. So it is an extremely important parameter. It is of extreme importance, particularly when we are talking about the extreme temperatures over which our IC engine is operating. So our lubricant should have a high viscosity index number. Okay, next property is of the flash point. So in this property, in this property of the flash point, the flash point is basically the lowest temperature. It is the lowest temperature at which the vapors of a lubricant oil will ignite when an ignition source is when it is exposed. You can say it is exposed to an ignition source. So as we know that we do not want our lubricant oil to ignite, so it should have a higher flash point temperatures, higher than the temperatures which are being usually achieved in the SI engines. So the flash point is the lowest temperature at which vapors of lubricating oil will ignite when an ignition source is when they are exposed to the ignition source. And flash point temperature should be high. They should be high enough than the temperatures which are occurring during the common operation. Next we have is a fire point temperature. Again, fire point temperature is that minimum temperature at which the vapors of the lubricating oil which have been ignited will keep burning even if the ignition source has been removed. So fire point temperatures are slightly above the flash point temperatures, and it is being defined as the minimum temperature at which the lubricant oil will keep burning even if the ignition source has been removed. So it is also desirable that your lubricant should have a higher fire point temperature. So again, as I explained that a lubricant should have a higher viscosity index number, a lubricant should also have a higher flash point temperature. Similarly, a lubricant should also have a higher fire point temperature as well. I hope it is understandable to all of you. So the main difference between the flash point and the fire point temperature is that flash point temperature is that minimum temperature, is that lowest temperature at which the vapors of a lubricating oil will ignite, and the fire point temperature is that minimum temperature at which uh, uh, at which the already burned already ignited lubricant oil will keep on burning even if that ignition source has been removed, and they both should be higher uh, uh, for the lubricant oils. Fire points temperatures are slightly higher than the flash point temperature of a same lubricant, and these temperatures should be high enough than the normal temperatures which are occurring in our IC engine. Alright, next we have a cloud point temperature. Okay, so here you can see that cloud point temperature is basically when we decrease the temperature of a lubricant oil, the lubricant oil will start changing its condition from liquid state to a solid state, and this phenomena occurs because of the conversion, because of the solidification of the wax content in the lubricating oil, and because of the conversion of this wax content from liquid state to the solid state, a cloudy appearance will start to appear, and that is why this temperature and at that point, at that temperature at which this cloudy appearance occurs, is known as the cloud point temperature. So when the lubrication oil is subjected to low temperatures, the oil changes from liquid state to solid state, and in some cases the oil starts solidifying, which makes it to appear cloudy. The temperature at which this takes place is called cloud point temperature. Okay, if we conclude that what are the desirable properties about the cloud point, if we are living in a country where the temperatures are extremely low, like Canada and Finland and Greenland, so in such countries the temperatures are quite low, so these cloud point temperatures should be very low. Means that lubricant oil should not solidify even at the low temperatures as well, so that your IC engine, your car, can be started at cooler conditions, cooler atmospheres. Now proceeding forward, next we have a pour point temperature. So pour point temperature is basically that temperature, that minimum temperature up till which the lubricating oil can be poured, means it can flow easily. Uh, if we go below this pour point temperature, we may have a better resistance against the flow. We may have a higher resistance against the flow of this fluid. So this property must be considered very carefully while selecting the lubricant oil, particularly in the cooler regions. And when we are talking about when we are talking about starting our IC engine in the cold environment, so it is the lowest temperature at which lubricating oil will pour. It is an indication of its ability to flow at low temperatures. Means the lower the pour point temperature of a lubricating oil, means it can flow, it can be poured at very low temperatures as well. This property must be considered because of its effect on starting an IC engine in cold weather. So just like the cloud point temperature, the pour point temperature of a lubricating oil should also be very low. So far we have studied 5 different properties. The viscosity index should be high, flash point and fire point temperatures should also be high, cloud point, while the cloud point and pour point temperature should be low for an IC engine. Next we have oiliness. Again, this oiliness basically is directly proportional to the film strength. The greater the oiliness of a lubricating oil, the higher the film strength, the higher the loads that film of a lubricating oil between the reciprocating between the moving components can bear. So this is a property which enables oil to spread over and adhere to the surface of bearing and all the moving components. It is most important in boundary lubrication. Means where the films are being prepared between the films are being made between the reciprocating parts. So it is of the great importance. Now so a lubricant should have a high oiliness as well. Now moving towards the next property, and that is the anti-corrosiveness. So as the name suggests that your lubricant should be anti-corrosive, it should not corrode the moving component, the reciprocating components, the rotating components of the IC engine, and it must retain its properties even if any foreign material and exist in the lubricating oil. So anti-corrosiveness means that it must not corrode the working parts, and it must retain its properties even in the presence of foreign material and additives. Emulsification. So emulsification, you're concluding the anti-corrosive that your lubricant should also have a higher anti-corrosiveness as well. Emulsification. So emulsification is basically the phenomena if the lubricating oil is mixed with the water. This phenomena is called emulsion, preparation of an emulsion, formation of an emulsion. And because of the formation of this emulsion, the lubricating oil loses its property for lubrication. Therefore, emulsification of a lubricant oil should be low. It should have a de-emulsified properties. It should not make a emulsion. If your lubricant oil is making an emulsion, then it means it will lose its lubricating properties much earlier and it will not provide the proper lubrication. Moving forward, next property is of the physical stability. So by the word physical stability, it means that the lubricant oil is made up of many components. It may have some mineral oil, it may have some fatty oil as well. It also includes some additives as well, and they all are being combined together to form the lubricating oil. So by the word physically, it means that even at the lowest and the highest temperature at which the oil is going to be used, it should maintain its physical stability, and it should not separate these components, and it should not vaporize even beyond the certain operating limits of the temperature. So lubricating oil must be physically stable even at lowest and highest temperature between which the oil is going to be used. At lowest temperature, there should not be any separation of solid, and at highest temperature, it should not vaporize beyond certain limit. So this is what the physical stability is all about, and your lubricant should have a higher physical stability. Next we have chemical stability. So in the chemical stability, again, it should not react chemically with the moving components or with some other component, with some other with the additives as well. It should not form any sort of oxides. These lubricants consist of olefins. These olefins form oxides which are gummy deposits, and it is undesirable. So your lubricant oil should be chemically stable as well. So the chemical stability of a lubricating oil should be high. Lubrication oil should have a higher chemical stability. Thus it should not have a tendency to form oxides. So your lubricant oil should have a higher physical and chemical stability. Now moving forward, next we have the neutralization number. So as the name suggests, that it is going to neutralize the amount of acid or maybe the amount of the base which is being present in the lubrication oil. So our lubrication oil might contain some impurities which cannot be removed during the refining process. So the neutralization number basically determines the acidity or alkalinity for that lubrication oil. The neutralization numbers are basically generally represented by the total acid number, or more commonly be written as TAN10. It is defined as the milligrams of potassium hydroxide which is being required to neutralize the amount of acids which are present in grams in the lubrication oil. So the higher the TAN number, it is undesirable. It is means it should contain, your lubricant oil has the higher acidity, and it is undesirable. So the unit for the TAN total acid number is basically milligrams potassium hydroxide per grams. Okay, after studying the total acid number 10, is there any number which is being represented by which is being written as total base number or TBN? So you guys will study this, you guys will research this by yourself in your as your homework. Proceeding forward, next we have the adhesiveness. So adhesiveness is basically the property which basically indicates the stickiness of the lubricating oil, that how sticky your lubricating oil can be. So this property is also very desirable, particularly when we are talking about the stickiness between the of the lubrication oil between the rubbing surfaces. If it will not stick with the metallic surfaces, it will not form a proper film. It will not form a proper film which will basically bear all the loads between these two moving components. So generally higher adhesiveness are required for the lubrication oil. But when we are talking about the operating conditions which are quite harsh, which is where we have a lot of cold weather, we may not require that much adhesiveness because it may offer, it may bear a higher loads, but may offer the higher resistance between the moving components. But generally, if we are talking about the adhesiveness, it should be higher. So next is the film strength. Film strength is generally directly related to the oiliness. Higher the oiliness, higher will be the film strength, and it basically represents that even at operating at the higher speed and higher loads, the film is not going to break. Means the lubricant oil will consistently form a thin film between the two moving components, and it will not break. So it is a property of a lubricating oil due to which the oil retains a thin film between the two surfaces even at high speed and loads. The film does not break and the two surfaces do not come in direct contact. Means as I explained earlier, as I mentioned, as I drawn the this diagram, that cylinder and piston should not come in contact with each other. The lubrication oil should form a film in between these two moving components. So this is what we're talking about in the film strength. So your lubrication oil should have a higher film strength. Okay, next property is of the specific gravity. Specific gravity is generally directly being measured with the density of the oil. It is indication regarding the grade of the oil by comparing one lubricant with another, and it is determined by the hydrometer. Hydrometer is that equipment which is being used to determine the specific gravities. So that's all about the different desirable properties of the lubrication oil. Next we have the additives which are being used in these lubrication oil if we want to achieve these properties, because generally these lubrication oils does not have the desired characteristics, and in order to achieve those desired characteristics, um, there are some additives which are being added to these lubrication oil, to these base oils, and some of these additives are mentioned here, like uh, detergents, dispersants, anti-wear additives, rust inhibitors. So these names are quite clear that what their purposes are. Like viscosity index improver, it would be improving the viscosity index. Pour point additives, anti-foaming agents, antioxidants, oiliness improvement additives. So the name suggests the purpose of these additives quite clearly. Moving forward, discussing the detergents, uh, the purpose of, as I mentioned earlier, that um, your base lubrication oil, base oil in the lubricant consists of some olefins, and at higher temperature these olefins will combine with oxygen to form oxides, and they will form a gummy material which will be deposited between the moving surfaces and may restrict the movement of these moving components. So what detergents do is basically they control the high temperature deposition such as gums, and they also act as effective acid neutralizers. They will avoid the formation of these gummy deposits, and not only that, but they will also be acting as an effective acid neutralizer. So next additives are dispersants. So, when we cool off the when we go to the temperatures which are quite low, some of the particles, some of the we can say, since this base oil consists of many components, some of the components like the wax component will start solidifying, it will start forming a cold sludge. And what these dispersants do, that they will avoid the formation of this cold sludge when we are talking about the low temperatures. So this is the main difference between the detergents and the dispersants. What detergents are doing, detergents are basically controlling the deposition of a gum at high temperature. What dispersants are doing, they are basically controlling the formation, they are controlling the deposition of a cold sludge at lower temperatures. So and the next additives which are being used is anti-wear additives, as the name suggests, that they will enhance the anti-wear property of the lubrication oil. So these additives will reduce the wear, and not only that, but they will provide extra strength needed to ensure that effective and efficient lubrication even under the severe conditions is being ensured. So what are the purpose of these additives? They will reduce the wear, and not only that, but they will provide the extra strength which is needed, which is required to ensure the efficient lubrication even if your IC engine is operating under the severe conditions as well. So the additives which are being used are chlorine and phosphate compounds. Okay, next we have rust inhibitors. So in rust inhibitors, as the name suggests, that they would be offering a resistance against the formation of the rusting. So they will what the purpose of these additives is, the purpose is to reduce the rusting by acid neutralization by forming a protective film. Next we have viscosity index improvers. As we can extract by the name that VI improvers are basically those additives which will increase the viscosity index number of the lubricant. Means what it is doing is, it is preventing the thinning of oil at high, even if the temperature changes. So the changes in the viscosity would be quite low. It means that it will have a higher viscosity index, so the viscosity index will be improved. So a higher viscosity index is always desired for lubricating oil, as it can be seen in severe winter and summer conditions. And for that purpose, high molecule polymers are being used for this purpose, as they are soluble in oil. These high molecule polymers will avoid the formation, will avoid the change in the viscosity even if the temperatures are changing. Recently, 15 to 20 years back, multi-grade oils have been started to produce, which consist of the properties of two different oils, which consist of a low viscosity oils within the thickening polymer. Their special ability is to adopt both summer and winter conditions. Means in summers they will act like some other lubricant, and in winters they will act like some other lubrication oil. I will explain that what these multi-grade oils are. I will explain these multi-grade oils in this video in quite some details. So what is the purpose of viscosity index number? Viscosity index number is that additive which will improve, which will enhance the viscosity index number. Means there will be lesser changes in the viscosity when even when the temperatures are being changed. Okay, so now moving forward, next we have pour point additives. As I explained earlier, that the pour points are that temperature, that minimum temperature at which your liquid, your lubrication oil can be poured, and these pour point additives, um, these the pour points of the lubrication oil should be low, and in order to achieve these low pour point temperatures, some additives are being incorporated. These additives are generally polymerized phenols or esters, and they are being used up to the 1% of the oil. So what these pour point additives basically do, they will uh, at extreme temperature, extremely low temperature, the base oil will start forming the wax crystals, and if if it is left unchecked, the wax crystals will start to coagulate, and will form a solid, will start to form a solid material which will suppress the flow of the oil. And these additives, these pour point additives, they basically uh, they basically do not allow the coagulation of these wax crystal. So what do? They basically reduce the pour point by interfering the wax crystallization. They do not allow the wax to crystallize. They do not allow the wax to coagulate. They do not allow these solid particles to start coagulating with each other. That's how they will reduce the pour point temperature. And as I explained earlier, that polymerized phenols and esters are being used up to the 1% of the base lubricant oil. Next is the anti-foam agents. These anti-foam agents are being used to reduce the oil foaming by causing the collapse of the bubbles due to air entrainment. Silicon esters are used as anti-foam agents. Means if we do not add these additives, what will happen is foaming will start, and the air bubbles will start to accumulate in this lubrication oil, and when these air bubble bursts up, that air particles will start contacting the surfaces, metallic surfaces of your IC engine, and they can start wear and tear, and they can start the formation of the rusting as well. So it is quite undesirable that the foams are being produced in the IC engine. So for that purpose, anti-foaming agents are being incorporated, they are being used. Next are the antioxidants. The purpose of these antioxidants is to reduce the formation, of the oxides, and they basically protects the bearings against the corrosive attack. Next we have the oiliness improvement additives. These additives basically enhance the oiliness property of the lubrication oil, and the substances which are being used are colloidal graphite and zinc oxide, and when they are added to oil, they will enhance the strength, they will increase the strength of the oil film which is being formed between these between the moving components. Okay, now moving forward, next we have the different types of lubrication which are being used. Uh, in general, we can classify, we can categorize the lubricants into two categories. First one is the oils, and the second classification is of grease. Greases are not generally being used for the lubrication inside the IC engine. Um, in oils, there are some other types as well. Like we have some mineral oils which are being extracted, which are being refined from the petroleum, from the crude oil. Then we have the fatty oils. These fatty oils are made from different plants, different animals. Then we have these synthetic oils. These are man-made oils, and in order to achieve the desired properties from this mineral and fatty oils, some additives are being added to obtain the desired properties, and that's why they are called synthetic oils. Then we have this. Then we have the multi-grade oils, which are nowadays being used for the purpose of a lubrication in our IC engine. And I mentioned earlier in the earlier slide that I will explain these multi-grade oils uh, in quite some details in this video. So starting off with the mineral oils, these mineral oils are generally being obtained uh, by the distillation, crude distillation process. And what happens in this crude distillation process, I will explain you that. For example, and this is my crude distillation unit, CDU. I will get some, let's say I get CH4 from the top, and then moving forward in some uh, in between layer, I will get naphtha, which is being used in, which is the fuel for the um, we can say, you can say for which is being utilized in the preparation, in the formation of a gasoline. Then I can have some different fractions as well, like kerosene oil. This kerosene oil is generally being used uh, for the jet fuels as well. Then I will have some fuel oil which are being used in running the boilers in our steam turbines. And in the last, we will get uh, some residue, and this residue is also of quite some importance. Okay, after this crude distillation unit, we have this vacuum distillation unit, and the residue of the CDU, crude distillation unit. The residue of the crude distillation unit is being sent to the vacuum distillation unit. It is the feed of the vacuum distillation unit. And then we will get some different grades of the base lubricant oil. And in the last, we get the different grades of bitumen which are being used in the preparation of the roads. So I know these phenomena as I have worked 4 years in the National Refinery. This was the basic process which happens in the National Refinery, and National Refinery was the only refinery in the Pakistan which basically makes the base lubrication oil. And these different grades of the base oil, let's say grade 1, grade 2, grade 3, grade 4, they are being named. I'm not going to I don't have enough space available to write down the name. I will not go into the details, even I will not discuss the details of the process as well. So these different grades are then being purchased by the marketing companies, and those marketing companies add some additives in it to achieve the desired properties, achieve the desired characteristics for the lubrication oil. And these marketing companies like Shell, Total Parco, Castrol, PSO, they basically purchase these products, and by adding some additives they sell it. But the base oil is coming from the refineries. So if we are talking about these grades which are being obtained after the vacuum distillation unit, these lubricants are called mineral oils, and we do not have any other additives in it. So we can achieve different grades of the mineral oil by the vacuum distillation process. So the mineral lubricating oils are obtained from the residual mass left during the crude petroleum distillation, which is this residue which is being left after the crude distillation unit. In this treatment, gasoline, kerosene oil and gas oil fractions are recovered from the distillate, like this methane. We obtain naphtha, kerosene oils and fuel oil. We will get different grades of fuel products. These paraffinic crudes generally give higher yield to the lubricating oil than the naphthenic crudes. The residue is then sent to the vacuum distillation unit. This residue is then being sent to the vacuum distillation unit, where the same phenomena will occur. This vacuum distillation tower may contain some bubble caps, some different types of trays like a chimney trays, or may contain some trays with a ballast units as well. And then they will basically make different fractions of this lubricating oil, and these different lubricating oil will have different viscosities as well. So that is how the mineral oils are being manufactured. That is how the mineral oils are being made by the refining of a crude oil. Next we have the fatty oils, and as I explained briefly earlier, that fatty oils are being made from vegetable and animals, and sometimes they are being used alone, but most frequently they are being used with the mineral oils. The purpose why they are being used with the mineral oil is that they exhibit poor keeping quality, means they will undergo decomposition during the lubrication. So in order to maintain its quality, so that it does not decompose, they are being mixed, they are being used with the mineral oils. uh, but these fatty acids, since they have a higher tendency to decompose, but these fatty acids provides more oiliness as compared to the mineral oils. So non-drying oils such as olives, castor oils, lard and fish oils are mainly being used for the lubricating purpose. Olive oil is generally being incorporated very widely in the textile industry, because we can wash away that olive oil without even leaving a stain on the cloth. Whereas we can use some different, like castor oil, we can use castor oil in heavy, and we can compound it with heavy minerals for making extremely pressure lubricants, which are operating at the higher pressures, which are operating at extreme conditions. So generally these fatty oils are being used in while mixing it with the mineral oils. Next we have the synthetic oil. Again, as I explained earlier, that synthetic oils are called synthetic oils because they are not obtained directly from the petroleum process. Some various processes are being incorporated in order to acquire the desired properties of a lubricant. For example, we would require a low pour point temperature, we will require a better viscosity index number, and we will require a higher degree of resistance to oxidation. Similarly, we do not want our lubricating oil to decompose at higher temperatures. So all of these properties are being achieved synthetically, and the synthetic lubricants which are being generally used nowadays are diabacic acid esters, organophosphate esters, silicate esters, silicon polymers, polyglycol ether, and some other related components. Next, before moving towards the multigrade oils, I am going to explain you the classification of the lubricating oil as per the Society of Automotive Engineers, SAE. The lubrication oil are normally being classified according to their viscosities, and Society of Automotive Engineer has basically developed a method of assigning a number to different oils which are generally being used universally. So SAE has assigned a number to an oil whose viscosity at given temperature falls in certain range, and the temperature ranges which are being used for that purpose is -18 degrees Celsius, which is the colder limit, and 99 degrees Celsius, which is the upper limit of that temperature range. Now SAE 5W, SAE 10W, and SAE 20W are different grades, and they define the viscosity at -18 degrees Celsius, and the property and the we can say the chances, not even we can say that they will operate more effectively, more efficiently, even at the cold weather starting conditions. So the W in this 5W represents the winter condition. So but when we are talking about, let's say, SAE 20, SAE 30, SAE 40 and SAE 50 grades, they are defined in terms of a viscosity, but the temperature limit here is not minus 18 degrees Celsius, but it is 99 degrees Celsius. It means that these oils, these grades of oil are going to work very satisfactory in the normal and hot climate conditions. So I hope it is clear to you that 5W, 10W and 20W means that they will operate very effectively when in the cold weather conditions, and W represents the winter, while SEE 20, 30, 40 and 50 represent the grades of the oil in terms of a viscosity at 99 degrees Celsius. Means they would operate quite satisfactory in normal and hot climates. These numbers are merely used for classification of oil according to viscosity, and they do not indicate the quality of oil, since factors like stability, oiliness, etc. are not considered by these numbers. Now moving towards the multi-grade oil. Now you guys have a clear idea regarding SAE 5W, SAE 20 grade oils. Moving towards the multi-grade oil, as the name suggests that this oil would be acting like a multi-grade oil, would be acting like some other grade oil at lower conditions and would act like some other grade oil in the summer conditions. So it is possible to develop an oil with more than one viscosity at different temperature. Thus an oil may be operating like SAE 30 at 99 degrees Celsius and like SAE 10W at minus 18 degrees Celsius. Oils of this type are known as multi-grade oil. Such type of oils are known as multi-grade oils. Other possible grades are 5W20, 10W20, 20W20 and 20W40. So I hope it is clear to you what does this multi-grade oil means. Most commonly you would see in Pakistan multi-grade oil of 10W40 and 20W50 is generally being used. If I am talking about the shell oil, the yellow color box of the yellow color cane of oil which you from the shell, which you can see in the in any oil lubricating shop, is of grade 10W40, and means the temperature range are given about the grades of the oil are mentioned in that pack, and the red one which is being used and is of the grade of 20W50. So the first number followed by the letter W, winter, describes the viscosity of a oil at low temperature. The lower the number, the thinner the oil is. Means the 5W grade oil is much thinner as compared to the 20W there. The thinner the oil, the better cold starting operation it will perform. The lower the number, the thinner the oil is. Thinner the oil at low temperature is good because it flows more easily. And is therefore able to protect the engine when it is started from the cold. The thinner the oil, the more cold environment it can start your engine. It can start your engine even in the more colder environment. The second number describes how thick the oil is. So so the higher the second number, the thicker the oil is. If it's too thin when hot, it may not protect effectively. If it's too thick, you may lose efficiency as well, or this it may provide resistance against the moving component. So um, what the car manufacturers does, they basically provide you the grade for that lubrication oil or whatever, or if you are purchasing some IC engine for the power generation purpose, they basically provide the grade of the lubrication oil which you will use in your IC engine. So um, that's all regarding the different types of the engine. These are some of the types of the engine. Next we have some of the advantages of the multigrade oils. As I mentioned that they can operate in winter and summer conditions, so there is no necessity to change the oil as per the ambient temperature. And not only that, they will also increase, since we don't have to change the oil over and over again, and they would be operating, that oil can operate in the winter and the summer conditions as well. So it means it will also enhance the engine life as well, and different viscosities can be achieved uh, while operating at different ambient temperatures. So it will provide easy starting and short warming up. It will reduce the oil consumption because you will not have to replace the oil over and over again. It will prolong the mileage between the decarburization, and it will provide excellent thermal and oxidation stability of a multigrade oil, and thus it will, because of this higher thermal and oxidation stability, it will protect against the rust, corrosion and wear. So as I explained earlier that we can classify our lubricants into two categories. The first one is oil. So far we have studied everything about the oil. The second is the grease. Greases are not generally being used in IC engine, but they are being used where the sealing is being done in even in our IC engine. But when we are talking about the lubrication between the moving components in our IC engine, then we use the liquid lubrication method, that is lubrication oil. So lubricating grease is a solid to semi-solid dispersion of thickening agent in liquid lubricant. So how these greases are being made? We have a liquid lubricant, and we will add the thickening agent in it, and because of the addition of this thickening agent, it will starts to solidify. Some other ingredients may have also been added to achieve the desired properties. Greases are normally used under conditions of lubrication for which oil is not as suitable or convenient. Greases perform better than oils under the conditions where high loads and shock loads have to be there, where we have slow journal speeds, and we have extreme temperatures, where cleanliness or avoidance of the splash or drip. In liquid lubrication, oil, what happens is we basically have a splashing of a liquid oil throughout the moving components of the IC engine. So in such cases where we do not want the splashing of a lubrication oil, we prefer to use greases. The greases also require minimum attention, whereas lubrication oil will have to change over and over again after some time, after some running hours. They can seal against some external contamination, And large bearing, these they are also being used where we have a large bearing clearances. In larger bearings we do not use a lubrication oil, we prefer to use greasings. So that was all regarding the types of the lubricants. Um, in the next class we will start off the topic of the lubrication system, and we will discuss some types of the lubrication system, like wet sump lubrication system, dry sump lubrication system, and in the last we will discuss mist lubrication as well. So in today's class, so far we have studied the basic introduction regarding the lubricants. We studied the basic concepts, that why this lubrication is required and what is the function of the what is the function of a lubricant. Then we discussed some of the properties of a lubricant, and we discussed quite some details regarding the properties of these lubricant. And since the we cannot achieve these properties until we add some additives, then we studied what additives are being used, are being incorporated. Then we had different types of lubricants, in which we can categorize different categories in which we can categorize our lubricants, and we discussed the details of the different lubrication oils in today's class. So I hope it is quite clear to you. Multi-grade oils are being generally used nowadays in our IC engine. I hope you guys would have understand the basic concepts regarding the lubrication system, and regarding the lubrication oils. And in the next class we will start off with the topic of a lubrication system. uh, uh, Go through this video very carefully, uh, try to understand the basic concepts, uh, and in case you have any question, just note down your question and you can ask your question in the online session or through the WhatsApp group or in the Google Classroom as well. So till next video, Allah Hafiz.